Hello, I'm Joe Vasta, and today we are going to be looking at completing the square. So you may have remembered in an algebra class where they wanted you to solve this equation, completing the square, and there was like a little recipe where I think you take the 6 and chop it in half and square it and add that to both sides. Well, where's that all coming from? Well, I'm going to go ahead and show you a geometric approach to this, just to kind of show you where the completing the square algorithm comes from. So what I have down here is a scale. It's really a simply drawn scale, a triangle and a rectangle. And this x squared is going to represent an area of a square that has side x. So let's put it on the scale. But we don't want it to tip, so I'm going to put my finger there. And so as you can see, this square has side x. The area of that square is x squared. Now, on the left side of the scale, I'm also going to put a rectangle that has area 6x. And so look, it has length of 6 and width of x. The area of a rectangle is length times width, so I have 6x. That's on the left-hand side of the scale. On the right-hand side of the scale, I want to put 13, but how do I put 13? Well, what I'm going to do is I'm going to consider these little tiny squares that have side 1. The area of that square is 1 times 1, and so I'm going to need 13 of those on the right-hand side of the scale. So here they are. And so now I can take my finger off the scale. It should be equally balanced. I'll also get rid of that little one on the top right of this slide. So that's what it looks like. That's x squared plus 6x equals 13. And both sides of the equation are represented by these shapes here, these squares and that rectangle. Okay, next step. I broke this rectangle right in half. There used to be a 6 there, now it's 2 rectangles. And what I'll do is I'll separate them a little so you can see the 2 rectangles. And so it looks like that. Now the scale is still balanced. I'm going to start moving some of those rectangles around. So I'm going to put the middle one on top of the square. And I'm going to move that other rectangle next to the square. And so I didn't change anything. It's still balanced. And what I have here is a big square that is not complete. And so what I'm going to do is I'm going to end up completing the square. How? By filling in this big square with these little squares here. Now I'm not going to take these ones. What I'm going to do is I'm going to add a little square here and a little square there at the same time so the scale does not tip. So watch this. And so you see this one got put there and that one got put there. Well, I'm going to do that until I fill up this part so I have a big square and I'll have completed the square. So here we go again. Watch both sides. There's the next one. And the next one. And the next one. So really, how many squares did I have to add on both sides? How many of these little 1 by 1 squares? Well, I had to add 9 of them. And so that's kind of what we did. We took this 6, we chopped it in half when we broke that rectangle in 2, and then when you square it, that's 3 times 3, which is 9, and that's what you're adding to both sides of the equation. I mean the scale. So here's the 4th one. We have the 4th one, the 5th one, 6th one, 7, 8, 9. So I've just completed the square. Now what I want to do is I want to see what the length of this side is. It's not going to be 3 times x, it's going to be 3 plus x, or x plus 3. And this side's also going to be x plus 3 as well, so we'll change that around. The scale is balanced, and now I'm going to write the area of this big square, which would be x plus 3 times x plus 3, or x plus 3 quantity squared. Now that should equal all the stuff over here, and you can count them up. 1, 2, 3, 4. What you'll end up counting up to is 22. Another way of realizing that it's 22 is I did add 9 of these 1 by 1 squares on the right hand side. So 13 plus 9 is 22. Or you can count them. Maybe that's funner for you. So we end up getting 22. And we have just gone from here. We completed the square and wrote the equation. X plus 3 quantity squared equals 22. Now, of course, you could then use the square root property and then solve for x. But the point of this demonstration was completing the square, showing you a geometric way of representing that. I hope you enjoyed this. Oh, by the way, one last thing I have to say. It probably annoyed some physics majors when I put a square there and I put a square over here. Yes, there's some properties of physics that I am disregarding. You know, like if you put something right here, it's going to affect this teeter-totter differently than if you put a square right there. So I just wanted to put that at the end of this video. Have a good day.